Hello and welcome to Java Collections. For today we'll be talking about vector. Vector is the first class, or the we can say the first important collection class that we will start discussing in this discussions. So vector is the first implementations of a growable array. The problem that we have discussed already with the difference between an array and a collections. So here comes the first solution, which is like the very first solution which was introduced by Java. The first version of my collections was vector. Vector implements a growable array. It can grow as per requirements. If you need to add more elements, it will grow itself dynamically. So like an array, it contains component which can be accessed using an index, which is like your integer index value, which will give me a exact pointer where my element is gonna insert. However, the size of array will not increase, but on the other hand, the collection type, the first collection type vector, this can grow. This can grow as per need, or it can shrink if needed. We can keep adding and keep removing element while iterating, while juggling around the collection elements uh, within use of my business applications for many of my business use case. Since vector implements list interface, it's a first class of a list interface. List um, Vector class has all the methods within vector class is they are the synchronized methods. Like we on a very figurative term we call it as a synchronized child. This is thread safe. It was used for all the thread safe purposes. Like ArrayList, it has an insertion order, but it is rarely used in a non-threaded environment. So we have all the method as synchronized, so this can be used heavily under multi-threaded environments. It's very thread safe collections. So as it is synchronized, it gives a poor performance. It gives some performance hits as compared to the performance synchronization of elements. Some of the commonly used method we have in vectors are like vector gives you a hell lot of methods. Like the the better thing about collection is when we use collections, we need not to think anything on this. We just have to know all the what are all the tools and whatever all the functions or methods which collection supports out of the box. If we know all of them, we can reuse them. We need not to write our own method unless it is very specifically required. So we need to understand the commonly used methods. We can start writing and using some of the most common methods which are used generally while writing some any business level logic or some any business component module of your project. See, we'll start with the first add element. We can add a new element in my collections, which is similar to an add an element. Then we can check the capacity of it and or the size of it. We'll come back on the differences between the capacity and the size. We can set the specific size of it. Then we can check whether my collection contains a particular element or not, or we can check whether my vector contains a complete new collections or not. I can come to an element if I know the particular index of my elements. I can see the first and last element of my vector class. I can retrieve an element by throwing the index value of it. If I want to get an element at particular index, I can retrieve that. I can check whether my vector is empty or not. We can remove a particular element. We can remove the complete collections, or we can set element at particular locations. Here's the basic sample code that we have. Before going there, we'll start writing some code and we'll come back and we'll revisit this. You can choose any ID of your choice. As I prefer IntelliJ, I'm just writing my vector demo. We'll start writing some of the common methods. We'll write a quick main method here, and then we'll start writing vector. Let's keep it specific to string. Make it my vector. We can make an implementation of vector here, and we can add some test elements over here. Like we can have Java. So with vector, we can start with our first 3 elements. So we'll take about every method one by one. To add a new element, what we can do is we can add over here. We can new string object. So we can add a new element over here. We can add this element at particular index also. We can specify the index location. Say I want to add it at the third locations. Make it a third indexed element. Just to test it, we can, and we'll see what my vector reference has. We just need to right click and run this program. See, initially we started with Java and C++.NET, then we added a new third index element. See, this is the third location, 0th index, first, second, and my third index. So on my third index I have mentioned my element should be the new element which I have added, and then the last element would be the new string object that we have added. We can add an element over here. Second is how to iterate through every element over here. Iterator to be used. What we can do here is my vector, we can call a method iterator. If we see the implementation, iterator gives me a reference of an iterator type which is specific to string. For this I need a placeholder of string and make it a my vector iterator over here. We'll go with the my vector iterator instance and we'll check whether it has the next elements. Until it has the next elements, we can keep printing all the elements of my vector class. Take a my vector reference and call it a next element over here. By this we have discussed this before also, and this is how we can iterate it one by one. Next element, what we see to check the first and the last element of my collection. We can have here my vector dot first element. So this will return the first element of my collections. Then we can use my vector dot last element. We can print them out. Something similar we can do for the first element here. We can remove this part. Next is to check whether my element is whether my collection is empty or not. Is vector empty? We can check over here my vector reference, and we have an isEmpty method which will give me a boolean value, yes or no, whether my element is my vector class is empty or not, is empty or not. We can check my collection is empty or not with my isEmpty methods. Going forward, what we can check is for my contains method. I can say, does vector contain a particular element or not? We can check the contains over here and see my vector dot contains. I can say Java. It will return me yes or no whether it has the element or not. See, we can quickly check this, but by the time we come over here, this method is already clear. Sorry, no, this is fine. We can make a quick check. We can right click and run this. See, we have printed these elements one by one using my iterator. Okay, so my first element of my collection is, if you see, the last element is new string object, first element is Java. Is my vector empty? It's false. No, my vector is not empty. Does vector contains Java? Yes, it's true, it contains Java. So we have so many methods over here which will give almost all the possible solutions which you need on your day-to-day programming requirements. Okay, so going forward, we can see we have got a contains. We have another method called myVector.contains_all. This contains all is basically talking about another collections. We can have a collection of collections. So for this, what we need to do is, let's say we create a new vector string. Let's make it a test a test vector, new object of it, and we on this test vector we put some element over here. See, we have test 1, and here I have test 2 and test 3. What I do is, in my vector I can add the complete all new collections. So here I am adding a test vector to it. Now my vector object has all the elements which was added to it, and it contains another new vector collections. Here what we can check about is, does a vector contains this new collection, that this new vector, this test vector or not. What we can do is we can have my vector dot, it contains all of my test vector or not. We can have added all, and we can just print this. Say updated vector is let's right click and run this and see what we have got. Okay, so here we were earlier. Test vector contains Java, yes. Updated vector is, it has all the previous value and these new test elements. Next is whether my vector contains this new collection type or not, yes or not. Next, what it support is, we have got my vector reference dot clone. We can make a copy of it. If you see the clone, it will return me of object type. So if I keep it, it would be of object specific. If I need it to be specific to vector, we have to make it a cloned vector here. This will not work because I need to typecast it. Since the return type is object, we need to typecast it to clone. So here we'll check the cloned copy of my vector. We'll right click and check the clone copy. Yes, we have made almost a duplicate replica of the earlier vector class that we had. It contained all the similar elements. Okay, moving forward, we can look into a couple of more methods of it. Now let's say I have got a vector, I have got a hell lot of elements into it, and I want to clear it out. Like, I don't want any more collections. Now when I print it, current status, if you see of my vector is, we'll right click and test it. See, it is blank now. We had cleared out. We have now, it has no element in my collections. We can comment this for now. What we can check next is, let's say my vector has a method to copy into. I can copy the entire collection of elements that we have into some array, which is of object type. So we need to create a new object for it. For this, what we do is, we have a string here, array of string. We give it a new string and we'll make it a specific to my size of my vector. So now I have got an array of string. What I need to convert is, I need to put my vector elements into this array. I copy into my array of str. So now we have converted a collection to an array. To access every element of an array, what we can do is, we can go through every element of it, string str into my array of str now, and we can print it one by one. Elements inside array are, we can just print them. We can right click and check what are we getting out of this. Okay, so the current status is, we have all the elements. Since I have commented the clear part, after this I have copied them into a new array. and now I'm accessing every element of array one by one, so we have got a similar element into an array format. After this, what we can do with vector is we can make a sublist of it. Let's say in sublist we are taking the starting index to ending index. Say we need it from my second element to my fifth element. We can directly print this out and we'll see a shorter version of my vector class. See, now we have taken only 3 values, second, third and the fourth. So it's like a sublist versions, which is like a subset of my bigger collections. These are some of the common methods which we use in vector. So coming back to the presentation, this is basic vector operations. We have an array, we taken the element one by one, first, second and third. Now we can add an element to a particular index, giving it index 2 element. Then we can retrieve an element by passing the index value. I can get the index at my third locations. For next, we can have vector first element and last element. Vector keep a record of what is the first element inserted in my collection and what is the last element. I can access it based on their location. Next, I can check whether my collection is empty or not. So here I'm checking my is empty part. After then, I can iterate over the vector using an iterator method. We can call on the iterator method, take the reference of iterator, and we can iterate through every element one by one using hasNext and the next element of my vector. Moving forward, we can make a cloned copy of collections. Clone copy is nothing but just a replica of the collections which can be reused or which can be forwarded to some other part of my applications. Then my vector could have a bigger collection could have a smaller new collections. Here I create a new list of ArrayList type or of any other type. I can add all. Add all will take the complete new collection type. So my list is of ArrayList. So I can put a complete new collection. Like this is collection. It can take any collection. It is not specific to vector. My vector contains a new collection of list within it. Next we are checking the collection of it, whether it contains this list which we have just added or not. We can similarly check the every element of it by using contains method as we have just seen. After this, we can to remove all the elements from my list, I use vector.clear. My vector would be cleared out. It will have no more elements. After this, we can create a new string array, an array copy of it, and I can copy all the element of my vector objects to this new array. And then we can access array elements one by one using a for each loop. Last was we can make a sublist of an array. We can pass the starting index or the last index. So by this we can convert a bigger collection type to some smaller versions. See, these are some of the out of the box supported methods which it's a good tool. It's something for every developer. We must have these things in our toolkit, that these are commonly method used. We have to make a conscious decision which method to be used at which part of my applications. Based on your input, based on your business requirement, you can use these methods. This is just we are trying to equip ourselves what all things we have ready to use for my collections. That's pretty much all we have for the collections. We'll talk about next topic in our next video. Thank you for watching.